When developers need to build an autonomous AI system today, the immediate reflex is to reach for a massive, pre-built agent framework. It promises instant scalability and rapid deployment with just a few lines of code. But importing that convenience creates a black box architecture. High point-in-time accuracy often masks the lack of visibility into the system's internal reasoning, making it impossible to spot a logic error before it hits production. We see the consequences of this blindness in the runaway loop. An unsupervised agent encounters a broken API or an odd edge case, and without a hard stopping condition, it frantically calls the same broken tool hundreds of times, burning through thousands of tokens in minutes. Treating autonomous architecture as an opaque dependency paralyzes engineering teams. When the system inevitably breaks, there is no clear path to debug or reclaim control over the machine. Behind all the abstraction, true AI autonomy boils down to a very simple, continuous 6-line while loop. It starts with the perceive stage. Here, the agent ingests an initial user prompt or new environmental feedback, gathering the raw data it needs to start working. Next comes the reason stage. The language model evaluates that ingested context and decides on the best strategic approach to solve the problem. That strategy moves to the plan stage, where the agent breaks its chosen path down into a sequence of discrete subtasks. Then we hit the act stage. The agent reaches out into the real world, executing a specific command, like querying a database or calling a weather API. Finally, the observe stage. The agent looks at the data returned from that action, checks if the overall goal is met, and if not, feeds that observation right back into the beginning to run the cycle again. This continuous cycle is entirely different from how standard chatbots work. A chatbot takes a single input, generates a single response, and stops. It operates in a straight line. By interleaving reasoning with action, this specific cycle, known as the react loop, gives the machine the ability to evaluate an error, realize a tool didn't work, and pivot to a completely new strategy mid-task. Mastering this loop allows a developer to hard-code strict iteration limits and cost budgets. It shifts power from the framework back to the human. Guiding that loop requires a shift from simple prompt engineering to engineering the entire knowledge environment surrounding the AI. Supplying the agent with persistent instruction files in the repository gives it a senior-level understanding of the system architecture from the moment it boots up. To let the agent touch your data securely, we use the Model Context Protocol, or MCP. It acts as a universal adapter, connecting the agent's reasoning engine directly to enterprise tools. Utilizing a standardized protocol like MCP eliminates the need for massive third-party integration libraries, further reducing bloated dependencies. Real autonomy is achieved by meticulously engineering the context and connections that surround the core loop. It is a product of systems design rather than framework installation. Moving away from architectural efficiency leads to the ultimate consequence of deployment. What happens when an autonomous system makes a critical error? This is the moral crumple zone. It describes the systemic difficulty of determining exactly where the blame falls between a human creator and an autonomous machine when things go wrong. Using an opaque, monolithic framework forces the developer to absorb all the blame. Because the system's internal decision logic is hidden, there is no way to accurately trace why the AI took a destructive action. But relying on the raw agent loop creates a transparent execution trail. Teams can log every reasoning step and tool invocation, making the machine's path entirely visible. This transparent observability allows engineers to pinpoint the exact node of failure. It separates a developer's logic error from an environmental data failure. Understanding the mechanics underneath the abstraction is the path to true ownership of an AI's actions. It is how developers move from simply talking to an AI to controlling its results in the real world.